theta upon r square. This is the value of dr d theta. Now let me write here. Therefore, ds upon d theta is equal to, let me now find out. Therefore, ds upon d theta is equal to under root r square plus dr upon d theta whole square. That is given as r square is this value, same value a square into cos 2 theta plus sine. Now dr d theta is this, so it will be whole square. It will be a4 into sine square 2 theta upon r square now. So this whole square of this dr d theta whole square, that means a4 sine square 2 theta upon r square. R square can be substituted. What is r square here? Let me now rub this. It will give us square root. Okay, I'll write that area. Area is here 2 times 2 pi. We took 4 pi outside. It was 4 pi, limits 0 to pi by 4 in this case, and it was here y r cos theta, sorry, r sin theta here. I just forgot this. It's r sin theta, value of pi into ds d theta. We were writing here ds d theta as, we are calculating here. It is ds upon d theta into d theta. All right. This is the value of y ds upon d theta d theta. Okay. And 4 pi are taking y, twice of 2 pi. For 2 pi y into ds it was. So 2 pi, 2 into 2 is 4. It is 4 pi we have taken. Now let me take this here. Now a square, okay, r square, let me substitute here. This is cos 2 theta plus a4 into sine square 2 theta divided by r square. R square is this. It is a square into cos 2 theta. Okay, so this a square, 1 a square cancel out. Cos 2 theta LCM, if I take, it will be now a square root of a square into cos square 2 theta plus a square, this a square left over, into sine square 2 theta upon cos 2 theta only left over. This is a, if I take outside, a square are taken outside as a, it is sine square theta plus cos square theta, that means 1. So 1 upon, it is cos 2 theta. That means this is nothing but a upon under root cos 2 theta. Try to understand. This is the value of this. Okay, now let us take, this is the value of ds d theta. Here I have to write this value. Therefore, required area is this. Therefore, required area of the surface generated, by revolution of this one loop about the initial line, or by both the loops complete arc. That means twice I have taken already. It is 4 pi, limits 0 to pi by 4. R I have to take here from this. R is a under root cos 2 theta. This is a into under root cos 2 theta. R, value of r here. Sin theta as it is. Let me write. ds d theta is a upon into a upon under root cos 2 theta into d theta. Now cos 2 theta under root cos 2 theta cancelled out. It is a square. Alright, it's 4 pi into a square, limits 0 to pi by 4. It is now sin theta only. Okay, this is sin theta only into d theta. Only sin theta is left over. No problem. Okay, so that will be, let me now substitute the value. The value of this, it will give us 4 pi a square. Now sin theta is integrated as, because sin theta is only left over value. So sin theta d theta. Because sin theta is integrated minus cos theta. Limits now 0 to pi by 4. Okay, it will give us 4 pi a square. Now cos pi by 4 is 1.2. It is minus 1 root 2. Sorry, minus 1 root 2. Minus sign is there. It is 1 root 2. Cos pi by 4 is 1 root 2. it is negative sign. Minus sign, in between it will be plus sign. Minus is already there. Lower limit, when we substitute, we put minus sign in between, so minus plus. Cos 0 is 1. This is 1 minus 1 upon root 2. Alright. Then nothing but 4 into pi a square. Then bracket it is 1 minus 1 upon root 2. This is the value here. This is the answer here. Okay, square unit. We can write it as 4 pi a square into 1 minus 1 upon root 2. Only. Okay, so nothing else is there. Only 4 pi a square into 1 minus 1 upon root 2. Any other change? Nothing else. Okay, this is the answer of this curve. Now let us take question number 7. What does question number 7 say? Let me check it. Still time is there. Now question number 7, what does it say? Okay, now question number 7 is, it says the lemniscate r square equal to a square cos 2 theta, okay, is revolved about a tangent at the pole. Alright. Show that the surface of the solid generated is 4 pi a square only. Okay, so 4 pi a square is there. That's the point. Now let us take the same curve. My curve is of the 6th type of question. 6th question, same curve is there. So here curve is lemniscate. Lemniscate is r square equal to a square into cos 2 theta. Now it says about the tangent. This curve is revolved about its tangent. The tangent of the curve was, as I just draw, let me take this initial line here, OX. The curve was, this is the tangent line, sorry, on the curve we can draw, and this is the curve here. Here is the curve of this kind. Let me take this curve here like this. Same curve. This is loop here. So one loop is this and other loop is this. What it says? It says the lemniscate this is revolved about a tangent at the pole. At the pole. Now show that the surface of the solid generated is 4 pi. Tangent at the pole. Tangent at the pole, let me take this is the tangent. Let me take this is OR here. OR is the tangent here, because tangent is on the this point. Okay, the curve is revolved about this tangent. If I take P point, let me take this is P point. Okay, and P is joined from the pole like this. Now if I draw perpendicular on the tangent, let me draw perpendicular here. So the perpendicular here is the perpendicular on the line. On the tangent in this case, this is perpendicular. Pn, let me take here. Pn, the tangent here, this is Q point. Let me draw Qn also. Q also. Okay, so this Pn only we have to find out, because we always find out in case when a curve is revolved about another line other than the axis. This is other than the axis, the tangent at the pole here. So that OR is the tangent here. Tangent is given. These two are tangent here. This is one of the tangent here. Now this is theta angle we have taken. Now this angle is pi by 4, because this is theta equal to minus pi by 4. Here this is pi by 4 angle. Pi by 4 here. Okay, so what is this length Pn here? So Pn in this right angle triangle. So Pn length will be, this Pn is equal to, this is perpendicular here in this right angle triangle, and the angle here is theta plus pi by 4, or let me take angle here, PON angle PON. Angle PON is equal to angle this, angle POX plus angle XON here. Okay, it will give us theta plus pi by 4. This angle is angle PON. This whole angle is theta plus pi by 4. Therefore, PN upon OP is sine theta or sine of angle PON. Got the point? But sine of angle is theta plus pi by 4. What this angle PON is theta plus pi by 4. That means PN is equal to OP. OP is R here. That is OP into sine of theta plus pi by 4. But OP is R. R theta we can take. This is R here. OP is R sine theta plus pi by 4. So PN is R sine theta pi by 4. Okay, that is the length PN we have taken here. Okay, so we have to find out now what is the area of this hole. So total surface area of this revolution, we have revolved this arc about the line this whole curve is revolved about. Now in this case, limit will be taken from minus pi by 4 to plus pi by 4. Because this whole curve is revolved about this, so limits are from minus pi by 4 to plus pi by 4. Okay, now solution we are finding out. Here the tangent, let me take tangent on the pole O is, let us take OR is the tangent. Therefore, angle PON we have already taken. Angle PON is equal to angle POX we have taken plus angle XON, which is nothing but theta plus pi by 4. Angle PON. Therefore, PN is equal to perpendicular length. PN is equal to R sine, which I have done already there. R sine theta plus pi by 4. That is the length of the RPN. Okay. Now let us take. Then what is the area therefore? So this area is also included, twice of this area, because this whole curve is revolved about this, and this also we have to calculate twice of that area, total area. It says this whole lemniscate is revolved about a tangent line. This tangent line, this curve is also included. That means twice of this. But limit here minus pi by 4 to plus pi by 4. Here it is theta equal to pi by 4. So limit should be minus pi by 4 to plus pi by 4. At the point here. Okay, so therefore limit here. Let me take this limit here. Okay, area of this. Therefore, area generated, area of the required area. Therefore, the required area of the surface generated is equal to 2 times. Why 2 times? Because this loop is also included. 2 times, let me first write area generated by one loop, generated by revolution of one loop, by revolution of one loop here. So total twice. So this is twice into 2 pi. Here limits are minus pi by 4 to plus pi by 4. Try to understand. Into 2 pi into by into this Pn into ds. Sorry, this is P into N into ds. Again, this is 4 pi minus pi by 4 to plus pi by 4. We have to take Pn is this R sine of theta plus pi by 4 here. Pn is into ds upon d theta. Okay, into ds upon d theta. Pn is this R sine theta we have already calculated into d theta. ds upon d theta we have to calculate. That is the next point. That we calculate, I think twice it. We will just calculate. So let me write here. Now we just calculated in the previous question. And what is ds upon d theta? ds upon d theta is r square plus dr upon d theta whole square. Dr upon d theta was from this equation. It was a square sine 2 theta upon 2 minus a square sine 2 theta upon r. It was so that was we obtained as a upon cos root 2. It was what? Okay, let me find out this. So this is r square. We just calculated here. It was r square is a square into cos 2 theta. So dr upon d theta was from this. We have to calculate. This was minus a4. So it was a4 sine square 2 theta upon r square now. Then r square we substituted that value. It was nothing but a upon cos root 2. It will come out cos of 2 theta. A into a upon cos of under root cos of 2 theta ds upon d theta is. Okay, this is there. So this we have to write here. A into that value cos of theta. Then r is then we have to put here. R is that value, so we will then solve it. So therefore, a upon cos under root cos 2 theta we have to substitute here in this formula. In this one. So let me now write what is the final value therefore. Therefore required area, total area. Therefore the required area of the surface generated is equal to, this is 4 pi minus pi by 4 to plus pi by 4 we have taken. Here is r is this is a under root cos 2 theta into sine of theta plus pi by 4. Try to understand. Here d theta is a upon under root cos 2 theta. We have just calculated into d theta. This cos 2 theta under root cancelled out. A into a square. This is 4 pi a square. Now sine theta is integrated as minus cos theta plus pi by 4 only. Limits are now minus pi by 4 to plus pi by 4. What is this? Answer of this. Let me now solve it further. Putting the limits here now. Now when we substitute upper limit pi by 4 in this place of theta, it will be pi by 4 plus pi by 4 means pi by 2. Cos pi by 2 is 0. So minus cos 0. Then lower limit when we substitute minus pi by 4 in place of theta, it will be then 4 pi a square. First is cos pi by 2 y, pi by 4 upper limit plus pi by 4, theta is pi by 4. Pi by 4 plus pi by 2, this is plus cos minus pi by 4 now theta place. So at theta we put minus pi by 4, minus pi by 4 plus pi by 4 is 0, this is cos 0. So it is 4 pi into a square, this is minus 0, cos pi 2 is 0, plus 1 only, this is nothing but 4 pi into a square. Okay, so we have to show that the surface of the solid generated is 4 pi a square. Complete. Same answer is obtained. This is 4 pi a square here. Try to understand. Same answer is obtained. Hence proved. So this area of this generated is 4 pi a square. Okay, this is the question number 7 here. Completely done. Okay, now it's clear. Now 8th question that we'll talk about. What is question number 8? Question number 8 is of what kind? Let me now check it. Question number 8 says a quadrant of a circle of radius a revolved about its chord. Show that the surface of the spindle generated is this. Surface is generated is 2 pi a square under root 2 into 1 minus pi by 4. You have to just check it. So a quadrant of a circle, a quadrant of a circle of radius a, you can revolve about its chord. Show that the strength of the spindle generated, so that the surface of the spindle generated is this. Question number 8 here. Okay, to so that this is the circle. Any circle is given. We'll take of radius A. A circle is of radius A. A quadrant of a circle of radius A. Okay. So a curve is here. A circle. If we take the circle x square plus y square equal to a square. It is r equal to 2a cos theta. R equal to, in this case, only this circle, r equal to a cos theta, r square. We put x equal to r cos theta, y equal to r sin theta only, then it can be operated. So this is the point. Now a quadrant of a circle of radius a is revolved about its a quadrant of a circle. Okay, is revolved about its chord. About its chord, find the. No problem at all. So about its chord only. So what is the circle? Let me now draw this circle here. So now this is the chord here. Now this arc of the circle is revolving about this. So we have to find out again. We take here P point, and this is perpendicular we draw, and here PQ let me take. This is PQ point. Okay, so this we have to find out. PN let me take here. This is M point. So A and this is B point here. Now radius of the circle is A. This is A0 and this is 0A. Radius is there. So this is A. This is A. What is the equation of the line here? Then we draw perpendicular from P to this line. So equation of the line is, let me find the solution. Here circle, equation of circle is x square y is equal to a square. That is given to us. Okay. In this case we will take in parametric form. So x equal to r cos theta. We will take here a cos theta, not r. A cos theta y equal to a sin theta. All right. Here x equal to, we will take a cos theta and y equal to a sin theta. In parametric form we will take it. Okay, so perpendicular we will draw first equation of the line. Equation of the chord. Now this is intercept form here. This is intercept. This is intercept. A and A are the intercept. Equation of the chord AB is x upon A plus y upon A is equal to 1. But both are A here intercept. So this is x upon A, this intercept. Sorry, x upon A here. This is x upon A, y upon A. So this both are there. So this is x plus y is equal to A. Or x plus y minus A equal to 0. So perpendicular drop from this line. And now P point, let me take A cos theta and A sin theta. Coordinates we have taken here. We have to solve it in terms of this. So length of the arc here, length of the perpendicular, length of PN, the perpendicular from P to AB. What is perpendicular length of anything? We write here. That is given as x1. Means this A cos theta into, this is x plus A. So this is 1 into, that means A into cos theta. Plus y is also A into, this is 1 into A into sin theta. Minus A divided by under root. Coefficient of x is 1. 1 is square plus 1 is square. That means under root 2 here. A we can take outside. This is cos theta plus sin theta minus 1 divided by under root 2. This is the length of the PN here. This is PN length. So PN is equal to this value. Okay, this is PN here. We have taken length of the perpendicular. PN is this here. Now we can find out what is the. Now in this case again, this length, this line is other than the axis. So the same formula of axis we have taken. Now limits we will take 0 to pi by 2. So therefore area of this curve obtained, area of the surface or required area required area of the surface generated by revolving arc APB about the line or the chord AP. In this case, other line, okay, other than the axis. So that formula we write here. This is twice pi. This is the limit 0 to pi by 2. Limit 0 to pi by 2 here, and this is pi 2 pi into Pn into ds. Pn into ds here. That we will write. So Pn is this value, and ds we have to find out ds upon dx. In this case, ds upon d theta we will calculate as dx upon d theta whole square plus dy upon d theta whole square. That we will calculate. Okay, so in this case, this is parametric form. I'm sorry, this is parametric form here that we have to calculate, not in R form. So this Pn is, let me write here. Okay, this completely let me write here. This is equal to twice pi 0 to pi by 2. Pn is this a into a upon root 2 into cos theta plus sin theta minus 1 into, let me write ds upon d theta into d theta. We will find out. Okay, now ds upon d theta in this case. So this is in terms of dx upon d theta we have to find out. Dy upon d theta we have to find out. So that ds upon d theta in this case will be under root of dx upon d theta whole square plus dy upon d theta whole square. This we will calculate. It will give us dx upon d theta from this equation is minus a sin theta. That means a square sin square theta. This will be dx upon d theta from this equation. Dx upon d theta equal to minus a sin theta, and dy upon d theta from second one is a cos theta, plus this is a square into cos square theta. We can take a outside. Under the bracket will be sin square theta plus cos square theta, which is 1. It is only a. Value of this is a. ds upon d theta is a here. Let me write that a. Okay, so this gives us a into a square. This is 2 pi a square upon root 2. I have taken outside into integration 0 to pi by 2. In bracket it is cos theta plus sin theta minus 1 into d theta. Now, or into a we have already taken, because in place of this a into a is a square, so pi a square I have taken outside. So under root 2 and this 2 in the numerator. So we will get, now let me start this. So we obtain required area. Therefore, required area is equal to this one. This is twice pi a. This is under root 2 only in the numerator. So this under root 2, if I divide by, rationalize this, root 2 into root 2, and in the numerator also 2 root 2. So this root 2 is 2 to cancel out, root 2 in the pi in the numerator only. Into pi a square, limits now 0 to pi by, let me now integrate that. So integration will give us, the integration of this cos theta is minus sin theta. Cos theta is sin theta, I'm sorry. And sin theta is minus cos theta. And minus 1 is theta. Limits now 0 to pi by 2. Okay, so that will give us what? Let me now write here limits. Solving it now. So sin pi by 2 is 1. So first is root 2 into pi a square within bracket. It is 2 pi and root pi. Okay, no problem. This will give us. Okay. Now this is sin theta. Sin pi by 2 is 1. Minus cos pi by 2 is 0. Minus this theta means pi by 2. Now when I substitute 0 at lower limit, so it is 0, sin theta is 0, but this cos theta will be minus plus here 1. Okay, why? Because cos 0 is 1. Minus will be plus sign, so it is 2. It is root 2 into pi a square, then bracket is 2 minus pi by 2. What the value here? If I take 2 or 2 out, this 2 out, it will come out as root 2 pi a square, then bracket is 1 minus pi by 4 here. Same way, I've taken 2 out of this bracket common. If I take 2 here, this is 2 root 2, that is 2 root 2 here. So the same answer is obtained. Here we have to prove that the answer is twice pi a square root 2, then the bracket is 1 minus pi by 4. It is 1 minus pi by 4. Same answer is obtained. 2 root 2 is outside, pi a square is okay. So this is the same answer we have obtained. Okay, this is question number 8 here. Now 9th question, let me talk about. Same answer is obtained, which is hence proved. This is the question number 8 we have proved. Same answer is obtained. Here the answer was given. What we have to prove here? That answer, let me write here. This is 2 pi a square into root 2 into 1 minus pi by 4. Same answer. This is 2 root 2. 2 root 2 is here. Because 2 I have taken out of this bracket. It will be 1, then it is divided by this, so pi by 4 here. Same answer is obtained. This is the same answer. This we have to prove here. To prove that area is equal to this, and this area we have obtained the same. This answer. Question number now 8 is done. Now let me talk about 9th question. Now question number 9. Let me think that what does it say? Question number 9 here now. Now here, question number 9. This is 7th question, and question 9 is this. Okay, and this is 10th question. Now question 9 says that a circular arc revolved about its core. Okay, find the area of the surface generated when 2 alpha is the angle subtended by the arc at the center. Okay, this is 9th question. What is given here? A circular arc, a circle. A circle is given. Let me take x square plus y square equal to a square is a circle here. Is not clear that circle is there. Okay, verify there. Then find the circular arc revolved about this. Okay, if I take that circle, let me take this is the circle here, semicircle here. Now